Hello everyone, this is the video lecture for College Algebra, Math 1314, Section 3.4. We're going to find some zeros. So, first off, it says, find the possible rational zeros of this big old guy. What is the possible rational zeros? Well, I'll just give you the formula right here. It is the factors of the last term divided by the factors of the first term. And I'm definitely making this a lot shorter, I guess. Using more common words, last and first. The real formula says the constant term and... Oops, constant is not spelled like that. Constant term and then the leading coefficient. Well, I'll just do LC. So leading coefficient and constant term. Okay, so what does that mean? It means the first and the last terms. That's what it means. And we're just looking at the numbers, and they're going to divide them, and we're going to find all the factors for them, and there you go. So first off, what are the factors of 21? So let's do that for the top first. Factors of 21 are 1, 3, 7. 3 times 7 is 21, right? And then 21. I'm just going to... I know, of course... I'm just verifying, yes, of course. Okay, and there's nothing else that I can think of, so that's good enough. In the bottom, we got factors of the 9. So 9 could be a 1, a 3, and a 9. So that's awesome. That's great. We need to be able to put that into the homework program, and so there's a couple versions that might work. And so first off, I'm going to take everything and divide it by the 1. And so we got plus or minus 1. Oops. Plus or minus 3, plus or minus 7, plus or minus 21. And then I'm going to take everything and divide it by the 3. So now we got plus or minus 1/3, plus or minus 3 over 3. Well, that's just 1. We already got it. 7 over 3. And then 21 over 3 is the 7. So we already got that as well. Okay, and then we're going to divide everything by the 9. So plus or minus 1/9. Then we got 3 over 9 is 1/3. We already got that. 7 over 9, that's something new. And then we got 21 over 9, which make the, well, actually, that's a really good question. 7/3 in the end? Okay, so we got a lot of different numbers. And yeah, that's awesome. That's one of the answers, but wow, that's a lot. So there's another version. We can do 1, -1. 3, -3, 7, -7, and no, I'm not kidding you. This is another way to write it in there. This is one of the more commonly missed questions just because it gets mistyped. And that, oh, we already have a 7/3, so I don't need to use it. Sorry, it's already right there. I was like, look at that. Okay, that's fine. And you could see that even then, if I would have duplicated one, the whole math program would have said, meh, you're wrong. And so there's a lot to write or type and all this kind of stuff. And in the end, it's a lot. Or it has multiple choice. That also could happen. You just click the one that has all that stuff and you're done. So this is your answer. I mean, forever how long it is. But why? Why are we doing this? What is this thing? Well, it's the possible answers, the possible zeros. I'm wanting to solve for x. See, set it equals 0, solve for x. And I need a list of possible answers to start with. And here you go. That's a list of possible answers. I'm going to ask you a question, though. Do you think 4 is ever going to be one of your answers for this guy? No, because it's not in my list. What about 5? Is 5 going to be an answer? No. What about 3? Could be. Could be. What about 10? Is 10 ever going to be an answer? No. So what you've done is take all x's and you've reduced it down to a pretty hefty amount, almost 20 or so, but you've reduced it down to some better set of numbers. I'm not going to say it's great, but it is better. And then you start testing and trying each one. And that's going to be the long way. Well, now we don't have to do that for this problem. Just let's find the possibles and move on. So that's good. We're going to do that, and we're going to move on. Number 2, they want to find the possible rational zeros, but then also find what are the zeros. I'd have to say this is a little easier, though, because I'm looking for the factors of the 75 divided by 1. And so it doesn't really have any fractions to speak of yet, and that's very good. And so what are my answers? Plus or minus 1. Is there a 2 in there? No. Is there a 3 in there? Yes. 3 times 25. 75 does not have a 4. Does 75 have a 5? It does. It's a 15. Does 75 have a 6? Nope. Does 75 have a 7? No. Does 75 have an 8? 75 have a 9. 75 have a 10. 75 have an 11. I'm just going through my calculator here. I know that it's silly to do that. I believe the next one is going to be that 15. 25. Oops. Plus or minus. And then finally the 75. I just was using my calculator and dividing. 75 divided by 5. Yes, and it worked out. 75 divided by 6. Nope. It was a decimal. 75 divided by 7. Nope, it's a decimal. Okay. So I got a list, and this is what you're going to do. You can either type it, you can click a multiple choice thing, whatever they're going to want at the time. Just do that. And of course, we can double it up and make it twice as long if you like, but the plus and minus button also makes it look a little nicer sometimes. So we need to find the zeros. We actually need to find the answers to this. Like set it equal to 0, solve for x, what would that be? And I'm going to recommend a graphing calculator. That's right. A graphing calculator will definitely help you. Desmos.com and etc. are great to be able to figure out what the answers are immediately. It will not always help you, though. It will. Okay, hold on. It will always help you. It won't always give you the answers. And so what we're going to have to do is figure this out with with synthetic division. And this is a nice testing question for that. We're just going to test it out. And so let's just start trying some numbers. I'm going to try 1. 1's an easy number, and it might work. It might not. So I'm doing synthetic division with, again, just one of these answers with all these here. And we're going to see 1 times 1 is 1, and then plus negative 3 is negative 2, negative 2, negative 27, negative 27, not 0. If I had a 0 here, due to like remainder theorem and stuff like that, you would actually have found a 0 for the entire answer. So we're looking for a remainder of 0. We did not get that, so 1 is not good. Let's try negative 1. Just going to try another one. So, and this is the process that you would do. Again, your graphing calculator will speed this up a great deal so that you don't have to go through every single iteration. You would just maybe have to do some of them. Yeah, that's not going to work either. If you know it's not going to work, it's not going to work. So both of those didn't work. Let's try the 3. And so in a way, what you're getting, like what you're looking at here is not an accurate view of what you really should be doing, but it's going to be accurate enough to be able to get the answers, I suppose. Notice I got a 0 here, but it's just a 0, so it doesn't matter. We want a 0 over here. And so I'm going to multiply it. 0 times ending is 0. 25, got a negative 75. And indeed, we got a 0 here. That's good. That's what I wanted. This is one of the answers. Go ahead and you already put that stuff in there. Right here in your zeros box, go ahead and put a 3, because 3 is definitely one of the answers. X equals 3. That's for sure. Okay, so look, we found it. It was one of my options there, wasn't it? What I want to do now, I could just keep going down the list, but that would take forever. So instead, what I want to do is write out what my quotient looks like and maybe go from there. This was x cubed, and now this is x squared. So I've got 1x squared plus the 25 is equal to 0. You don't need a 0, of course, so look at this for x. There's a couple ways to do this. Of course, you can just factor it if you know what's going on. It's a perfect square, but you can also just move it over to the other side, square root both sides, plus or minus 5. And look, those are the other answers right there, both of them. So 5, negative 5, those are the other 2 answers, and you're done. I knew that there would be 3 answers total because right here, this is a cube. And so if, whatever your degree is, the highest power on your boss, whatever your boss says, that's the amount of zeros that you're going to have for the entire function. Okay, so yeah, we're going to do that again. So here we go. Again, we got possible rational zeros and then find the actual zeros. Notice this is a 1 and that's a 9, and this makes it very simple. Factors of 9 are 1, 3, and 9. Everything's divided by 1, so it doesn't really matter. It's a pretty short list. Short enough that I want to list out all my answers just longwise, okay? So this is like my longwise answer, but it's going to help me whenever I'm going to find some of these answers with synthetic division. And so again, I totally recommend graphing this on the calculator, and that would help you a lot. But in the meantime, I'm not going to show that. I'm just going to, do it by hand up here to prove that I guess you can do it by hand. But I really hope that you're using a calculator to help you. 1 times 1 is 1, -1, -1, -11. Again, a -11. Ooh. -11 there. I think we're going to get a 7 out of that thing. And so 7 is not a 0. So that one didn't work. -1. Trying another one. And we're going to just keep on testing them until we get something to work. -1, -3. 2 negatives make a +3. -7. +7. That's going to be a bigger number, and that's not going to work either. Okay. If you go through the entire list of numbers and you didn't ever find one, what happens is that you probably just messed up an answer somewhere, and I do that myself all the time. So just watch out for that kind of thing, okay? It should work. One of these should work here. So I got a 3, a +1, a 3, a -7. That's going to be a -21 to make a 3. That's a -3, and 3 times 3 is 9. 9 and 9 makes a 0. So we got it. X equals 3 again. So go ahead and put a 3 down. We definitely got one of the answers. And so that's cool. We found it. So I want to find out what this looks like here. So we started with a 4th power, and I guess what we have left over is a cube. So it's the 4th, now it's a cube. 1x cubed plus 1x squared minus the 7x minus 3. Right here, cubed, square, regular x constant. And we're still trying to find a 0 for this. Now, the thing is that I still don't know what to do here with this one, okay? And I did purposely choose harder problems, I admit it. So I chose a little bit of a harder problem. So what do I do now? Well, I can't factor that, and I can't see anything. I don't know what to do. So you're going to just keep on doing synthetic division. But now, let's be careful with this for a second, okay? I'm going to keep going down my list and see if there's anything else. But my list is kind of short here. And I could make it dramatic for you, but rather I just tell you the proper way the first time. Is that you should try the x equals 3 again. Okay? Now, in the whole big scheme of things, it's probably not going to work. I honestly don't know what the answer is going to be, but I'm going to try the x equals 3 again, just in case you have a multiplicity. So you never know. Let's just try it. So 3 again, but with the new numbers. And so that's 1, again, x cubed, 1x squared, -7x, and then minus the 3. So we got a 3, a 4, a 12, a 5, and that's not going to work. Okay, so we tried it. The 3 still is good. This is still a good answer, but it just didn't happen twice. Okay, it didn't have a multiplicity. It just had once. Multiplicity 1, I suppose. Okay, let's keep going. So -3. Let's keep going with the reduced numbers here. Hopefully we can get something. So we got a -3. -2, 10 to make a +6, -1, 2 negatives make a +3, and sure enough, that also is one of the answers. So x equals -3 is also an answer. Go ahead and put that in the answer box here, -3. And you saw that we actually have 4 answers total, so let's just see what we have left here. I have x squared minus 2x minus 1 is equal to 0. Again, this was x cubed. Now this is x squared when you reduce it down. And I need to factor this. I need to solve it. I need to do something with this guy. And so what 2 numbers multiply to 1 but add up to a 2? And you're thinking it's 1 and 1. And man, that would be awesome if that were true. The thing is that, yeah, you need the 2 negative 1s to make a -2. But if you multiplied -1 and -1, you should get a positive here. You would get a positive 1. But that's not what we have. We have a -1. So this actually does not work. It just doesn't work. We can't factor that. So what do we do in the event that we cannot factor? We're going to use quadratic formula. Yep. Be familiar with quadratic formula because you will definitely be using it. Now, just as a reminder, x squared minus 2x minus 1 equals 0. That's a 1 in the front. So A, B, C. And here's my formula. I'm going to use capital letters because, well, they're easier to read with my handwriting. That just simply put. Okay, and then 2 times A. Good. Okay, so that's my formula. So negative of a negative 2 plus or minus the square root of negative 2 squared minus 4 times the 1 times a negative 1. I didn't like how that looked there. Okay, there we go. And then all divided by 2 times the 1. So 2 negatives make a positive 2. 2 negatives make a positive 4. 2 negatives make a positive 4. Then all divided by 2. So I got square root 8 all over 2. All right, awesome. Well, that looks like a great answer, but they want you to reduce it down some. So we need to reduce this thing down a little bit. And so what you're going to have to do is look at that square root 8. So let's look at the 8. And I want to see if I can reduce it down. So is there a 2 in there? Yes, leaves a 4. Is there a 2 in there? Yes, leaves a 2. These are the prime factors of the 8. And so you can actually rewrite this as 2 times 2 times 2. Okay, so that's what I'm just going to rewrite that 8 as 2 times 2 times 2. But the reason why I'm doing that is because with the square root, you can pull out the pairs. Pull out the pairs. And so there's a pair that are the same. You can pull it out to the front. What it looks like then is 2 plus or minus a 2. You leave 1 behind, and there you go. I left that 1 behind right here because there was no other pair with it. It has to be pairs. So if you had like 2, 2, 2, and then another 2, sure, go ahead and pull it out. But you have to have a pair of them, and so we had a pair of 2s. We got him out. This one didn't have any pairs with him. He's just kind of hanging out by himself, so you leave him behind, actually. I know there's a ton of 2s here, and that's kind of weird, but what we have to do is cancel a 2 everywhere. And so you're going to distribute your denominator, and so that's actually 2 over 2, and then 2 squared of 2 over 2. These cancel here to make a 1, and these, again, cancel here to make a 1. 1 times square root 2, essentially. And so my final answer for these last 2 zeros is 1 plus or minus square root 2. And wow, that took a journey just to find those answers. All the way back here, I have to get more room. So let's do this, because I want it to look pretty. 1 plus or minus the square root of 2. And again, do you use a plus and minus button, or do you have to type it the long way? It's I don't know. I can't tell you. It's whatever the program says. So there you go. Either way should be fine in the end. Math-wise, you're great. So, and there we go. Wow, that was a long program, or a long problem for the program. Sorry, that was long. And so just like going back, that was a lot of steps. Oh my gosh, it just keeps going. Wow. Guess what? Let's do another one. So number 4, same thing, doesn't ask for possible rational zeros, but sure enough, I'm going to be doing that. So plus or minus 1, 2, 3, and 6. So I'm looking at these numbers. And you might be wondering, hey, would a graphing calculator like Desmos would have helped me on even the last problem right here? The answer is yes, it would have. It would have shown you these 2 answers, but not these. And you'll still have to do quadratic formula. And so expect it. Even with a graphing calculator, there is no way around it. You will eventually need to do the synthetic division to get to the quadratic formula stuff and etc. So we're doing the same thing here. I'm going to start with a 1 and see what works. Again, I personally would love to have a calculator right now and just, pop it in and at least get some of these answers. But it's not going to happen. So there we go. Yeah, I'm getting like 50s and stuff. That's not going to work. You can also, I hope that you're seeing that you don't have to be perfect. Yeah, you don't have to have perfect. You have to have perfect math, of course, but you don't have to be perfect about exactly the flow of it, I suppose you can say. So this is a negative 19, so that's a positive 19. I think we're actually getting somewhere here. That would be a negative 6. 2 negatives make a positive 6. Yeah, there we go. So negative 1 is one of my answers. It's negative 1. I'm going to try negative 1 again, but with the new numbers. If you try it with the old numbers, it'll always work, because it worked. So you need to try with the new numbers. Negative 1, negative 7, positive 7, negative 12. That's not going to happen. Okay, well, we tried it again. Okay, so let's try 2 with the new numbers now. 2, negative 4, negative 8. That's not going to work. Okay, negative 2. Get a little bit of room there. Negative 2, negative 8. 2 negatives make a positive 16. And so that would be a negative 3. 2 negatives make a positive 6. And yeah, we got it. So x equals a negative 2. So negative 2 is another answer. Cool, and those are all part of my group there. Well, if you're noticing here at this point, this is going to be an x squared minus the 8x minus the 3 equals 0. And yeah, guess what? Quadratic formula. So that's why I chose this problem. I didn't just randomly choose it. I said, hey, let's do a hard one so that you're prepared in case you get to some crazy stuff on your homework program. So let's do this thing. Quadratic formula. It's a 1 in the front. And so we got a negative of a negative 8 plus or minus the square root. Negative 8 squared minus 4 times the 1 times the negative 3, all over 2 times 1. So we've got an 8 right here in the front. 64 plus 12 all over 2. 78? No, 76. Sorry, 76. I should probably just use a calculator all the time. Okay, so the 76, I think I can reduce that down. So 76, does that have a 2 in there? Yes. I'm using calculator just to verify. Yep, 38, of course. Is there a 2 in there? Yes. And it's a 19. And 19's prime, so you're actually done there. This is the prime factors of the 76. So we got 2 times 19, and then all divided by 2. Just like last time, whatever you have, just pull out the pairs. Here we have a pair of 2s. It could be a pair of 3s, a pair of 5s. It doesn't really matter as long as it's a pair. And so what it would look like, I'm going to try to use my colors, coordinating my colors here. That would just be a single 2 now in the front. But then we leave behind the 19 like that. So those 2's became that 2. So distribute your denominator, and so you get 8 halves. You get the 2 over 2 here is going to cancel. And so what you actually get is a 4 plus or minus the square root of 19. And that is your final 2 answers. So 4, 19. Wow, I need a lot more room. So again, I want to make it look pretty. So hold on. 4 plus or minus the square root of 19. Good enough. There we go. We did it. Whew. And there's another one. So, yep. This one says the graph, and honestly, this one's an easier one. If it says the graph, then you should probably use a graphing calculator. Just a thought. But let's just do it anyways. Possible rational zeros, we can see it's the factors of 18. So that'd be a 1, a 2, a 3. I don't think a 4, but like a 6 would definitely work. And so I'm going to just start trying some numbers. Again, if you had a graphing calculator, this is done instantaneously. And I'll show you why with this problem. But I have to kind of do it backwards because I don't actually have a calculator with me. So I got a negative 1, positive 3, 3, 18, 18, and 18 cancel, make a 0. Cool. So we got like one of my answers was 1, x equals 1. And we should definitely try it over again. But if you notice, we have the, I guess we have a quadratic. So it's negative x squared plus 3x plus 18 still equals 0. And I think that there might be a way to factor it. What I want to do is switch all the signs. And you can do that because you're basically just moving everything over to the other side here. So can I factor it? It looks factorable, right? So what two numbers multiply to an 18 but add up to a 3? And I'm guessing that's going to be a 6 and a 3. So a negative 6 and a positive 3. So therefore we get x equals 6, x equals a negative 3. And those are my other answers that I'm going to put up here. Okay, awesome. So there we go. We got our 3 answers. That was way easier than the last problem. And so I want to graph it. And so your graph for this problem would look like, I got negative 1, 2, 3. There's a 0. I got a 1. There's a 0. And then 2, 3, 4, 5, 6. There's a 0. And you're just crossing through each of them because they all have a multiplicity of 1. But, you know, it's just a basic, cubic, I guess you can say, a basic cubic. Cool. And so there you go. Click that. You're done. Part A, Part B. But can I use this to understand how to use the graph to get my answers quickly for all the problems here? Well, let's just say you had a graphing calculator, you did it, and you got this Part B first, right? So you got this, and now I want to find out what my zeros are for Part A. Well, if you go and look, this is, well, that's negative 3. There's a 1, and there's a 6. Oh my gosh, I hope that they would all work and plug in right there. Boom. Like, that's it. You just plug it all in. That was it. No problem. So what you're going to do with the other problems earlier is that you can graph it and you can see these whole number answers, and that's going to be part of your answer. And from there, you can at least get a lot better results. You don't have to do so much synthetic division because you know what synthetic division you have to do. You don't have to guess anymore. So in a way here, like on the last problem, you wouldn't have to do this. You would still have to do that. You wouldn't have to do this. You wouldn't have to do this. You would still have to do that. And then you would still have to do all that stuff beyond there, okay? So you still need to do all these processes. It would just speed it up for you. Okay, that's all I got. Thank you very much, and have a great day.